What I think I'll do, if there are no questions, since we have an hour, and if people are interested in sticking through another, sort of 20 plus minutes, I'll talk a little bit more about. Yeah, so I think we'll just sort of talk about some more of the concepts. I wanted to talk a little bit about sort of how we got here, because um, to me, clouds and the applications behind clouds are really the reason that we're talking about this. Um, I find it interesting. I've been in this industry for 20 plus years and have both managed systems and thought just about, my space is the only space that the world exists around. Having been a sysadmin for many years and then a data center admin for a number of years as well. Running field teams, selling products, doing all the sorts of things that I've done over the last 20 years. One of the things that has always struck me is that it's so easy to fall into the cycle of thinking that one technology answers all ills or resolves all the problems that we might see. But if we think about how applications have shifted, and specifically how the development of applications have shifted, I think it drives one of the reasons why cloud has become such a compelling and important component in our industry. Um, and if we look at sort of the initial sorts of applications that people built, well, these were software applications, or the very early days, pluggable applications that defined how services were supposed to be deployed, and they were tied specifically to the computer that they were built for. Often, and even in the case of something like an analog computer, the computer and the application were one. Basically, the controls built the computer. If we looked at things like ENIAC and some of the early compute systems of that nature, there were software programs. People did actually program the system, but it was often in a very laborious sense. So a very slow process of programming it, but you did actually have a flexible computer. It could do multiple things. That was one of its real benefits. But one of the interesting things about the monolithic stage was that effectively the developer and the software manager and the operations manager was the same person. Somebody would write the program, and often they would then actually implement the program themselves and operate the system, because there was no operating system. It was you working directly with the computer. It was a very, very tight coupling. Um, when we moved to distributed environments, we saw a real shift. Whereas it used to be one tightly knit team that developed the application, developed the computer, programmed the computer, did everything as a team. There was effectively one system. There was no separate systems administrator or storage administrator or network administrator. Um, Everybody sort of worked together to make something happen. As we got to many smaller computers, sort of the distributed computing world, we suddenly saw this massive shift in that there were folks that only wrote applications. There were folks that only managed the system itself. There were folks that then managed the different components of the system as the system became more and more distributed. People that only managed network, only managed storage components, for example. So we saw all those sort of components come together. And lastly, we saw this sort of this disaggregation of that one solid team. Yes, there was still sort of an IT group that managed maybe a bunch of these things together, but within that there were very siloed complexes. What we're seeing today, though, especially with web scale application development and the ability of automating your infrastructure and automating your services through this cloud model, is that suddenly the developers have come back into that one team that manages everything. A development team would actually manage the infrastructure that they're consuming by automating that infrastructure deployment, by using this on-demand self-service capability for getting their infrastructure deployed, managing the long-running state of that service, and also writing the software and managing and manipulating the software itself. So really, suddenly, the developer became that end-to-end resource for managing the application. And that's the shift that we're seeing. And I would say, actually, even beyond this, today we're seeing another shift, which is that we're again seeing a disaggregation of these resources, and that the container model changes the application developers' approach to infrastructure, separating out the infrastructure resources from the actual application deployment resources. And that's a big shift that I think is just starting to take hold now. Not that containers are new technology by any means, but I think the way that they're being consumed in the capacity and quantity of consumption is really sort of changing how these things are being defined. But I think we can see this application history driving also how computing resources are consumed. If we think about it from that perspective, in the monolithic stage, it was all for one and one for all. You wrote your application, you owned the computer effectively when you wrote the application, and that was really all you had available to you. In the distributed sense, the resources were still very expensive, they were very large potentially, and you still had to get a share of it, so you had somebody who managed what you had access to. And that sort of is anti the cloud model that we have today, where we're trying to share an elastic set of resources, yes, against some limits, but those limits are much, much, much larger than we ever would have seen in the past. And that's, I think, the big shift that we're starting to really see that's driving this big change. So we can look at this another way. This is a diagram that I think sometimes makes it a little bit more clear. We used to look at special hardware with a specialized application, and potentially, if it even had an operating system and wasn't directly written to the machine code itself, a specialized operating system that ran on that hardware. And it was all in one and one for all. Often the software developer and operating system manager were the same person or the same set of people that managed that kind of resource. In the microprocessor and mini computer sort of days, yes, we still potentially had a specialized operating system, an operating system that worked for that particular computer, but there were many more of them, and so we ended up with a specialization just to manage that operating system, a specialization just to manage the distributed storage that might have gone through that distributed systems environment. And the application was something that was then layered on top of that environment, and potentially the systems operators also had to deal with how that application ran, making sure and maintaining that application environment. And then lastly, we see the model that looks a little bit more like it does today, where we might have entirely virtualized operating systems and applications, but because we've virtualized them and we've given the developer potentially the access to those virtual resources because they have this on-demand capability of doing so, we've seen a big shift in the number of applications and how they're being deployed, and the fact that really the developers are also the operators in many cases today. Now, I would say there's probably a fourth layer of this that can now be added to this today, which is the container model, where the application developer view of this system is really just the fact that they have a bunch of applications that get deployed, and not so much that there is an application tied to an operating system tied to a physical system. And that's a big shift that's also happening, and that ties into this same on-demand service. It's only because it's so easy to request another resource, to request another web server or another web endpoint, really, if I'm not even thinking about the physical server or the virtualized server anymore, but just my application component provides a web service endpoint, basically a web address that I can actually go query. And if I don't care about the operating system anymore, I don't have to manage the network connectivity anymore, I don't even really care about the storage, just as long as I have somewhere to store the bits that I need to store. That's a big shift that's happening, and it's being driven by the application. So really, cloud, if we want to think about it this way, is the application environment rather than the actual underlying systems environment. But in order for the cloud to work, I need elasticity, I need to be able to measure the resources, I need to be able to pool them, I need to be able to get access to them from anywhere I'm at, and most importantly, I need to be able to do that on demand through a self-service interface. So, if we look at all these pieces, again, application developers are the ones that are driving this request. They're saying, hey, I need this capability. And why do I need it? Because I can actually get my job done more rapidly. I don't have to overburden IT departments by asking for resources and having them manually potentially create these resources. Or even when they had it automated, still putting in another step in the process of trying to get a resource available for doing development. So we really do accelerate the development. And classically we talk about, I grew up in a world where the waterfall development methodology, if you guys have run into that, was basically the only way we thought about things. You had a period of time where you did development, and you had a period of time where you did quality assurance, and you had a period of time where you did further integration and quality checks, and then finally you might release the product. And a product release cycle might be on the order of months or even years for many releases. I think many of us lived through that particular era. What we're seeing today, though, is that product releases are potentially happening on an hour-by-hour, if not even minute-by-minute perspective. If I can create a feature and function and test it and validate it at some level of system scale and then roll that out into production, that really changes how I build my applications. It changes the ability to be responsive to customer requirements and demands, because it's a lot easier for me to say, well, if a customer is saying that they really don't like the background color because they can't read the text on my page, and I can change that parameter almost instantly after having tested to make sure that that doesn't break something else somehow in some odd way. That's an incredibly powerful component, again, driven by the application itself. Right? We're not driving these changes by the infrastructure. The infrastructure is supporting a change that enables better application deployment and services. So really, we have a new development paradigm. Right? I can now develop much more rapidly. Now, not everybody does what somebody like, I think Airbnb was saying that they potentially release to production 300 or 400 times in a month. Very few people are at that particular rate of scale. But the fact that there are people that can actually now do this, they can use these automatic elastic resources to build their systems and release at scale multiple times in a day even, whereas in the past it would be multiple times in a year that you would release something. That's, I think, a really impressive capability that the cloud has brought to bear. So really, we're looking at how we enable this. We're looking at how these services can actually make the cloud a better space, but it is driven by the fact that the cloud enables this for all of us in a much more functional fashion. So while the cloud is this great and wonderful thing, and I think in most cases, if you can use it, it's a great thing, there is something that people talk about when they talk about cloud, which I probably ought to add a slide to this deck at some point about it, and it's this concept of pets versus cattle, or named resources versus unnamed resources. Resources that you have to care about because the resource itself is the thing that makes everything go, versus a resource that you can delete and recreate. My world at work today is effectively one where I'm constantly deleting an entire environment and rebuilding it. I mean, my test environment gets rebuilt at least 4 or 5 times in a day. Now, part of my deployment process takes hours, so it's not like I can do this on a second-by-second basis. But that's because I have a lot of systems and a lot of components that are not quite as flexible or functional as the container model might let me get to at some point in time. But the concept that an application might be more flexible is great if your application is. There are still plenty of applications that were never built with this kind of flexibility in mind and actually don't do well in infrastructure that fits into the cloud space. Now, the reason for this is that most people build cloud systems without the same level of care and performance and resiliency that they might build a classic enterprise data center environment from. Classically, because systems were expensive, because the software development cycle was so expensive, you would build a system and you would potentially provide some resiliency or redundancy for it, but you'd provide multiple network links, multiple access paths to storage so that any one path could fail and your system would continue running. In some cases, people even built hardware that was internally, x86 class hardware, for example, that was internally resilient. It could deal with an entire CPU dying and yet still keep running. And there are certain applications which need that level of resiliency even today. But the change in how applications were possible to be built, specifically I would say the Amazon Web Services change in application deployment, really made a major shift in how people thought about applications and what they could do with them. So applications started to be built to fail so that you could recover rapidly from a web interface failure. And actually, we've been sort of trained to deal with these failures very, very often. And actually now even the web browsers have gotten smart and sort of deal with some of this for us. Much like our use of cell phones has trained us to expect a call to not always work, expect a connection to potentially die in the middle of a conversation, and we just recall that redial into that conversation. That kind of training has happened even in the web services space, where we expect that occasionally we'll get an error and the system will just automatically retry for us, or we'll click the refresh button and get right back to where we were. Our shopping cart, if we were on a website where we were trying to buy something, will still have all of our resources in it. And that's because of a number of changes in the application deployment model. But if those changes haven't been implemented, then that application may not fare well in a classically deployed, or at least what I now think of as a classically deployed cloud environment, because the infrastructure was never intended to support the level of resiliency that a non-web scale application expected? So that's actually, I think, a really important question to ask when looking at the applications in an environment, when looking at, is something really cloud enabled or cloud ready or not, right? Because not everything is, and there are still plenty of applications that are the backbones of businesses that are by no means ready to be turned into cloud scale applications and thrown onto an Amazon Web Service, for example. So very important components. And at this point, I've been talking for about 50 minutes, and often I find that's about what people can actually handle. We do have another meetup scheduled, and I think it's in 2 weeks. And we were going to talk a little bit more about how customers are, or how companies and customers are actually using these different cloud resources. Um, if you haven't registered for that meetup, and if this one was interesting to you, please go to the meetup page, look under our Cloud Basics meetup group, and register for that cloud session.